Hi guys, and welcome to this screencast back onto exercise physiology, specifically looking at the aerobic system or aerobic training. So if we look at the specification, topic area, aerobic training continued down here. This is what we need to be looking at over the next couple of lessons. Today, the main focus is going to be aerobic capacity and VO2 max, how VO2 max is affected by individual physiological makeup or genetics, training, age, gender, and also methods of evaluating aerobic capacity, laboratory test of VO2 max using direct gas analysis, multi-stage fitness test, Queen's College step test, and the Cooper 12-minute run. Then we'll be going on to the other sections in later lessons. So please get your corner notes ready or your pens and papers ready to complete some corner notes on what we have just gone through there. So first of all, here are some past exam questions. There are a lot more. However, this is an example of what you might be asked to deliver. So, 5 marker here. Describe the use of direct gas analysis as a method of evaluating aerobic capacity. You may be asked to compare direct analysis to multi-stage fitness test, for example, or one of the other tests. Another one, an elite marathon runner will have a very high VO2 max. Describe how age and gender can affect VO2 max. That's a 2 marker. And then an elite marathon runner will have a very high VO2 max. Evaluate the importance of high VO2 max for an elite footballer. And that's a 3 marker. So we're going to start with the definition of aerobic capacity. So what is aerobic capacity? It is the ability of the body to inspire, so breathing in, transport and utilize oxygen to perform sustained periods of aerobic activity. So that is the definition of aerobic capacity, and it is dependent on the efficiency of the respiratory system, the cardiovascular system, muscular system, and obviously it's one of the components of fitness, really good for endurance-based work such as long-distance running, triathlons, open water swimming, cross-country skiing. Another key part of aerobic capacity is VO2 max. Now, VO2 max is the maximum volume of oxygen inspired, transported, and utilized per minute during exhaustive exercise. Okay, so that is the definition for VO2 max, and it is measured in milliliters per kilogram per minute. ml.kg.min. So if we move on to factors that affect our VO2 max. So what makes my VO2 max different to someone else's VO2 max? One of the factors we need to be aware of is training. On the left hand side here we've got effect on the VO2 max and we've got the explanation. So if we're talking about training, aerobic training must be used to improve VO2 max. No other type of training, aerobic training. So we're looking at high intensity interval training and continuous training. Please add that in there. Okay, so aerobic training must be used to improve VO2 max. For example, continuous training and high intensity interval training. The explanation in terms of what aerobic training causes, it causes or improves the strength of our respiratory muscles, i.e. our diaphragm, internal and external intercostal muscles. It also increases our left ventricle of the heart, so heart size increases. We have an improved level of hemoglobin, myoglobin, and mitochondria, which is going to help with oxygen delivery for aerobic respiration. So we also need to be aware of age being a factor that affects VO2 max. From early 20s, VO2 max declines approximately 1% per year. The explanation behind this is a lost elasticity of the heart, or due to a decreased elasticity of the heart. Another factor we need to be aware of is gender. So, females tend to have a 15 to 30% lower VO2 max than males from the same age group. This could be due to the fact that females have smaller lung capacity and lower hemoglobin levels. They also have higher percentage of body fat as well, which can contribute to having a lower VO2 max. Finally, genetics or physiological makeup we have to be aware that percentage of slow oxidative type 1 muscle fiber types determined by genetics can increase VO2 max. Or if you have a high percentage of fast glycolytic type 2B muscle fiber types, that's going to decrease our VO2 max. The type 1 obviously has more mitochondria and more myoglobin and a higher capillary density as well. So they are factors that affect VO2 max. Please ensure you are getting questions for those that give you those answers. You might go one question for the effect, one question for the explanation. So we're having 2, 4, 6, 8 questions for this section here. So methods of evaluating aerobic capacity. So first of all, the methods of aerobic capacity, how we measure it, and then secondly, the strengths and weaknesses for these. The first evaluation that we need to be aware of is direct gas analysis test. Okay, we'll watch a video lesson on this so it makes it more evident of what you'll need to know. So first of all, the performer cycles or runs on a treadmill. This is how we do or complete the actual test. So performer cycles or runs on a treadmill. This is to exhaustion. This is known as a maximal test. Okay, so this test is to exhaustion as it is a maximal test. What happens is the expired air is measured and then it is plotted on a graph and VO2 max is calculated. This is a direct, accurate measure. It's called direct gas analysis test. This is a direct measure. Okay, it is objective. It is our actual accurate measurement of VO2 max. Things we need to be aware of is we need specialist equipment for this, okay? And the person delivering the test needs to actually be kind of like have an idea of how to do it because it's not easy to do. For this test, you are wearing a mask as well. It's not suitable for the elderly or those with health issues. So when it comes to evaluating these tests, this is going to be on every single slide from now on. We need to be aware of advantages and disadvantages. So questions we need to ask ourselves or our evaluation framework when we're interrogating this type of question. We need to know, okay, is the test a maximal or submaximal test? As you can see, this is a maximal test. Is it a direct or predicted measurement? This is a direct measurement. It's accurate, okay, it's an objective measurement. It's called direct gas analysis test. Ease of use. Is it easy to use? I.e. group size, is it cheap, is it simple? This needs specialist equipment, okay? It is not simple, it is not easy to use. It's also not suitable for the elderly or those with health issues. So we have to ask ourselves suitability. Is it suitable for people with health issues? Is it suitable for the elderly? That's direct gas analysis test. Next test we need to be aware of, we've got the evaluation framework still on the right hand side. This is an athletics track. I realise it looks more like a go-kart track, but I like to keep my images black and white. So this is the 12-minute Cooper run. Performer runs as far as possible on a track in 12 minutes. This is a maximal test to exhaustion. How we measure it, distance covered is compared to normative data. And this is a prediction, okay? This is a prediction of our VO2 max. This is not a direct measure. So maximal or submaximal, maximal, direct or predicted, predicted. Ease of use, this is easy to use. You can do large numbers, it's cheap to set up and it's simple and easy to set up. Suitability, it is not suitable for the elderly or those with health issues, mainly because it is a maximal test. We are going until exhaustion, which we can't really have the elderly or people with health issues doing. Next one is a multi-stage fitness test. Multi-stage fitness test. Performer runs 20-meter shuttles in time with bleeps. That's how we perform the test. This is a test to exhaustion. It's a maximal test again. The level achieved is compared to normative data, so that's how we measure it. So we get a level, we compare it to a table with normative data on and see if we're classed as excellent, average, and so on. It is a prediction. Okay, so again, it's a predicted measure of VO2 max. It is not a direct analysis or direct, accurate, objective measurement. It is a prediction. Large numbers, cheap, simple, easy to set up. Suitability, it's a maximal test, so it is not suitable for the elderly or those with health issues. We have got Queen's College step test. Performer steps on and off a box at set rate and time for 3 minutes. This is a sub-maximal test, i.e. we are not working to exhaustion with this test. What we do is we take our heart rate during recovery, and this is measured and compared to normative data. Therefore, it is a prediction again. So this is predicted measure for VO2 max. It is not an accurate measurement. Ease of use, you have to get a box which is a specific height. But it's still cheap and it is still pretty simple to set up. And this one is suitable for all. It is suitable because it is a sub-max test. Okay, so it doesn't have to go to exhaustion. This, like some of the others, is not sport specific. We'll go on in a bit more detail about that in lesson. So they were the 4 tests that we need to be aware of. This is an example of a question that you might have to answer in lesson. Describe the use of direct gas analysis as a method of evaluating aerobic capacity. So make sure you've got some good Cornell notes on that, and I'll see you in lesson. Thank you. Bye.